So after identifying these native plants and fungi that can grow on these industrially contaminated sites and picking the top ones, I then tested those on 3 super contaminated sites in Los Angeles. And we saw really promising results for the whole mix of contaminants found there.
All right. I am joined today by Danielle Stevenson. Danielle, thank you for being on Urgent Futures.
My pleasure.
So you've been on Urgent Futures before. This sort of redux or bringing you back on for the rapid response is on the occasion of the Los Angeles wildfires and the aftermath of the Los Angeles wildfires, which Jane Williams calls the disaster after the disaster. And I wanted to speak with you because you're both an environmental toxicologist and somebody who has worked extensively with mycoremediation or bioremediation or eco-remediation. We'll sort of get into all of that. So you have a clear understanding of the problem we're facing and the solutions, or maybe not solutions, but responses we should consider for those problems. So I think to start us off, there's a lot of toxic pollutants in the air. What are they and why are they so harmful to humans and to the environment broadly?
So when there's an urban fire, it creates this toxic stew of pollutants ranging from metals like lead to organic contaminants like benzene and other pretty volatile contaminants to formaldehyde, even PFAS, the forever chemicals you might have heard of, sometimes even radioactive waste can be mobilized. And all of this happens because when structures burn down, all of the pollutants that go into not only the structures, buildings, homes that we live in, but the cars we drive and all the other stuff that's around. So it's a particularly toxic stew. There's another type of contaminant called dioxins. People might have been hearing with regards to the fires. Yeah, they get produced specifically when other pollutants burn. So, or particularly with fires. So, we're talking a lot about air, and folks will have been impacted by all of the smoke that's spreading these kind of toxic pollutant-containing ash all throughout the city. But eventually, what's in the air will settle on soil, typically, or in water. The stuff that settles onto soil can stay there, or when it rains, as we just had some rains, can wash into stormwater, into the rivers, into the groundwater, and out to the sea. So really soils and to some extent water potentially are the major sinks for pollutants that are released through wildfires and fires.
That's super informative. And I guess maybe not to put too fine of a point on it, but I think people can more immediately understand why these pollutants being in the air is so dangerous. But why is it so dangerous for them to be in the soil and in the water table?
Yeah, so when smoke and ash and volatile pollutants are in the air, or even non-volatile, even metals like lead, really when there's pollution in the air, it's really hazardous for folks because, and all life, because we can breathe in those contaminants, and that's not good. That's not good. That's what I think your last speaker spoke of as like the disaster after the disaster, or that's a component of it. But it's also really problematic that these pollutants settle in soil. And that's because many of them don't break down ever. That means that, not only the properties that were directly impacted by fire, so the structures that burned down, but even properties that had ash settle on them can be now contaminated with, metals and super recalcitrant, meaning like really, really hard to break down or even impossible to break down contaminants. So it's in my last conversation with you, we talked about this kind of like don't look down scenario where LA region was already dealing with just a huge coverage of contaminated soils and contaminated sites, right? Especially in the urban areas, but also all around Los Angeles and greater Los Angeles. So the problem is exacerbated by these fires, which not only it essentially created a whole number of new contaminated sites, but also spread, toxic stuff all over the region. So it's really important. So right now, many homes and properties are undergoing hazardous, assessment. So they're having testing done, and that's all organized through the state and federal agencies, and that hazardous debris should be removed over the next 6 months or so, and testing should confirm that it's all cleaned up, but there's a couple problems that still remain. One is the sites that weren't directly impacted that may have had, again, that ash settle on them, so they might be a little bit contaminated now. It's hard to say without testing. And there might be some residual contamination left behind even after hazardous debris removal is done. And then we have the massive amount of hazardous debris, so basically pollution, that has to go somewhere, right? So it's a really big problem, and yeah, urban fires like this just create such a toxic kind of disaster scenario.
Yeah. It's really overwhelming. I think this is a good point to bring in your body of research. You've emerged as a true visionary in a field called mycoremediation, though you've started to use ecological remediation. Talk to me about, I guess, first of all, for folks who haven't seen or listened to the first episode, which sort of, plug to go do that. It's a great episode, super informative. But maybe in a nutshell, what is mycoremediation and ecological remediation? And then let's get into talking about what the nature of your research was while you're doing your PhD and since then.
Yeah, so first of all, remediation just refers to cleaning up pollution in the environment. And so when we add bio or myco or phyto onto that, we're just talking about working with living organisms to do that, to clean up pollution in the environment. So I've focused a lot on mycoremediation, working with fungi to clean up pollution because fungi had been so overlooked in this field, even though they have incredible capacities to break stuff down and build healthy soil and help plants grow and all kinds of other capacities. But really, I'm trying to bring us to an understanding or an approach that mimics nature more. So in nature, we don't usually see a single type of organism. We don't just have like one type of plant. We see a diversity, and diversity leads to resilience. And it also just works better. So I'm trying to move us towards ecological remediation, which again mimics nature, works with ecological principles, and works with plants, fungi, microbes, and all kinds of life to clean up pollution.
Hmm.
So, yeah. So, in my PhD, I identified native plants and fungi and other amendments that have remediative potential. And so the reason this uh, is helpful, I hope, right now is that, of course, native life are adapted to the conditions here. Many of them are actually adapted to fire, even. And so I did a massive survey of contaminated sites in LA area and Southern California and picked those kind of top uh, fungi and plants that are both native and were addressing the contaminants of concern. So it turns out that the contaminants found on industrially contaminated sites and the conditions found there are actually really have a lot of similarities with fire impacted sites, especially where structures have burnt down. So you see not usually just one type of contaminant, but you see whole mixtures of really, really nasty toxic stuff. So after identifying these native plants and fungi that can grow on these industrially contaminated sites and picking the top ones, I then tested those on 3 super contaminated sites in Los Angeles. And we saw really promising results for the whole mix of contaminants found there. So this sort of led to a pretty promising model for soil bioremediation for LA specifically, using, again, native species that are adapted to the conditions here, and also showed a lot of promise in cleaning up mixtures of contaminants in really poor impacted soils.
Mm. You referenced these plants being adapted to fire. I'm assuming that's like how people have been talking about chaparral. Like, what can you talk about that?
Yeah, so a lot of, I mean, this is an ecosystem, a landscape that has been impacted by fire. It's fires have been happening here for a really long time, and yeah, so plants, and some fungi too, actually, that grow here and have been growing here for a really long time are adapted to either have their like to either be able to regrow quite quickly after a fire. Some even need fire to germinate and sort of sprout and start their life cycle. So that's what I mean by adapted to fire.
Wow. And it also speaks to this idea. I mean, you referenced not you sort of drifting away from the term microremediation toward ecological remediation to implicitly get away from that mechanistic approach of like throw mycelium at it and solve the problem. It seems like with what you're describing, it seems like you need a lot of trial and error and a lot of like relating to a place and to a landscape to really understand what remediation is actually going to work there. Is that me, you know, taking liberties, or would you say that that's how it works?
No, I think that when we're faced with really complex problems, we need really complex interventions or ways that we approach um, making a difference, positive difference. So yeah, I mean, a lot of indigenous folks to this area have known this for a long time and have intentionally worked with fire to maintain, healthy landscapes. Um, yeah, and I think I get a little um, tentative about sharing like the types of specific species that I've worked with, because I fear that people will apply that like just that mechanistic approach without considering really carefully the site and the land. So I think for folks that do have a long and deep relationship with a specific landscape, then this could probably be applied more effectively and thoughtfully. But yeah, it just doesn't usually work very well to kind of just drop in a species, especially when it's not adapted or suited to the conditions or the contaminants.
In our last conversation, you described how ecological remediation compares to more contemporary remediative methods. And when I spoke with Jane Williams a couple weeks ago, she echoed that the EPA and a lot of the and to an extent, obviously, some of this is needed, I assume, but that actually the way a lot of the remediation is going to go is just trucking a lot of the toxic soil elsewhere. So I guess my first question before I ask any more is that how you imagine things are going to go with the current situation post wildfires?
Yeah, I mean, that's really the go-to method. It's still the the main method that's used for everything from contaminated soil, post-fire cleanup, to how we deal with waste, right? So it does seem like um, that kind of dig and dump approach is already underway. And um, it's why I continue to test and advocate for more research into and application, not just research, more research and application of some of these alternative approaches that can clean up soil in place, right? Removing that need for it to just be dug up and hauled away. And I mean, a caveat there, um, if we're talking about really high concentrations of radioactive materials, the truly like most harm reduction method of cleanup might be to have folks with proper training haul that stuff away, right? So this really isn't, these alternatives ecological approaches to cleanup aren't gonna be suited to every single site, every single context where remediation is needed. But I do really think there's a lot to a lot to lose if we continue with the status quo. We're not going to be able to, dig up and dump elsewhere all the contaminated land and debris and waste indefinitely, right? So there's a major reason to, many reasons actually, to explore these in place methods, especially for sites with contaminants that can be addressed with these methods and sites with just a lower risk.
Got it. And on the flip side, it sounds like from our earlier conversation, like doing ecological remediation effectively requires a certain amount of research that one has already done, but also a really rigorous assessment of the nature of the contamination to understand how to remediate it. I assume that there's a lot of people who are like very urgently wanting kind of solutions deployed. Like I can only imagine how many emails you're getting right now. How like what do you sort of say to all of that?
Um, yeah, I would say to slow down. And I say that with a lot of care because my heart is breaking too. This is just really overwhelming, and I get the urge to take action and do something. And at the same time, these are just long term processes that we're in, and we can often make more thoughtful plans when we slow down. So, yeah, like you said, to be able to work on a project like this safely and effectively, one would need probably HAZWOPER training, like significant safety training and understanding how to work on hazardous sites and with hazardous waste and stuff, and what PPE protective gear you need, PPE stands for protective gear, protective equipment, actually. Yeah, you need to even so there's kind of an understanding, I think, now that you need to test, like you just said, to understand the range of pollutants and their concentrations. But it's also really important that you take soil samples properly and test for the right things and know how to interpret those results. And also, soil testing is really expensive. And yeah, and then you're going to need to then design your intervention, keeping in mind, I would hope, the specific context of the site. How close is it to a wildland? What type of what's needed on the site? What is the soil like? Is the soil destroyed? Is there, is there a possibility of releasing a potentially invasive fungus or species with your approach? What might be the byproducts of your approach? I could go on. And then, of course, you're going to have to test at the end to see how it went, right? And so all of that to say, these are the types of things that we offer training and whole programs. They're like 12 to 14 week programs that train people in these all these types of things: how to design a remediation study or pilot, how to take soil and environmental samples for contaminants. You get your HAZWOPER certification and things like that, just because we're dealing with such toxic sites. And I just really want to stress that hopefully people take good care. And if you really want to be involved in toxic cleanup, this is like one of the highest levels of toxicity. And so please do so safely with proper training and really thoughtful design of your intervention.
Mm. Well, you said we offer. I'm assuming you mean CARE.
Yeah.
So
Yes.
could you tell folks what the Center for Applied Ecological Remediation is?
Yeah, absolutely. So this is a nonprofit. So CARE is a nonprofit I founded. I've been long working towards this. And the purpose of Center for Applied Ecological Remediation is to advance research and application of ecological remediation, and to equitably address pollution, promote public health, and provide education and workforce development while building climate resilience. So there's a lot in there. And this comes from my 13 or so years in this field, seeing all of these gaps. Like, we need more research, right? Into these methods. But then there's this need for training and workforce development and education. Like, you can't study this stuff anywhere. And all of this, I would hope to really be done in an equitable way that really contributes to climate resilience and public health. So the center is all about working with and in communities that are most impacted, and collaborating wildly to try to address these issues in a more kind of systemic way.
Mm. You brought up HAZWOPER, obviously. Could we zoom in a little bit more on what a training program like for something like HAZWOPER is like, but also what the workforce development programs you've already done, but that are now you're applying even further through CARE?
Yeah, so HAZWOPER is a 40-hour certification that is offered through the Occupational Safety Health Authority, OSHA. Okay, it's kind of a weird order. Yeah, so it's not done through me by any means. It's just a federal certification that's required for many industries. So I actually was required to do this before I was allowed to step foot on a contaminated site, and even do any sampling or anything else, let alone do a remediation effort. So it's a good thing to know about if folks want to get into this field. Then get your HAZWOPER certification. And yeah, the types of programs we're offering, we've been doing with just a number of community partners over the years. It started with a high school near the largest contaminated site in LA 3 years ago. And we've also carried out bioremediation programs, certificate programs with Orange County Environmental Justice and a number of other community groups. So we're hoping to expand the request for these types of programs is growing a lot. So we're hoping to expand the program and get funding so that it can just be something that is continued to be offered, and hopefully even certified, something sort of like a HAZWOPER for folks who want to get involved in bioremediation work or just want to learn more so that they can develop their own community research programs using bioremediation.
Unfortunately, it will only become more necessary as time goes on. So it's amazing that CARE offers this. Could you also talk about the case studies from your own research and share a little bit about the results that you observed that give you the confidence that ecological remediation is, more effective or more robust than current approaches?
Yeah, so I've worked on a number of projects over the years, on probably most of the wastes or contaminants that were mentioned, other than radioactive contamination. Haven't done that yet. That's intense. Yeah, I would. Just would need more training. Here I'm demonstrating. I would
Right,
need
in your
more
free time.
training. I'm currently do not have the adequate training to mess around with radioactive materials. So yeah, I worked on a whole bunch of the probably most relevant here are the LA studies. So I did work on, again, 10 sites overall, 10 industrially contaminated sites around Southern California. And we tested these top combinations of fungi, different types of fungi and native plants, and other amendments that are accessible from the waste stream of the city. And tested them under different climate scenarios too, which I don't always talk about, but actually, the research has always looked at at climate resilience. So the major way we tested that in the LA studies was by having half the plots be in drought conditions and half be under adequate irrigation. So we ended up finding out that these combinations of plants, especially with the fungi, which have been missing from a lot of past studies, showed really good removal of a whole range of metals, which don't break down. So this was really exciting. We also saw good, very, very good results across all organic contaminant categories that we tested. So everything from, solvents to gasoline and diesel and polycyclic aromatic hydrocarbons, which is a major fire contaminant. And we saw these results in a 1-year period. So that's a pretty fast timeline, actually, if you consider that, a lot of this cleanup that's just literally scrape it up and dump it is going to take about 6 months, if not longer. So in about a year, we saw really good results. And if we had more time, if we take more time, then we could probably work towards a complete remediation.
This is an interesting point, the sort of timeline question, because yeah, I sort of assumed that any proposed ETA is optimistic, just because I feel like there's a lot of incentives to sort of make it seem like it'll be as fast as possible, and I don't mean that. I'm not like pointing a finger or sort of disparaging
Yeah.
anyone. I just, my general attitude with sort of major things like this, I mean, look at any construction project, they're always delayed. And I assume that something similar will play out with the remediation effort across Los Angeles. Also, because I'm not entirely sure that all the factors are being taken into consideration. And like what Jane was bringing up about the Port of Los Angeles being the biggest port in America. And so then also all of the sort of supply chain bottlenecks, like all the different factors kind of coming together, I just worry that it'll take longer. So it's like, yeah, ecological remediation might have a longer timeline, but could conceivably be done faster even than the method that's being used. And or perhaps there's a way that that method could be used only, like you mentioned, radioactive waste, only in places where it's really necessary. And then we're applying ecological remediation everywhere where everywhere else, basically.
Yes, absolutely. And yes, for both this fire cleanup and for remediation in general. I think there's so many cases where these ecological approaches would be much more appropriate. Um, and and then there's some in which conventional remediation or cleanup is just going to be the most appropriate. And so I think it just totally makes sense to apply a mix of those. And for LA to be able to pull that off, we're going to need a trained workforce that can, carry out these methods. And we're going to need sources of like at scale local native inoculum. So those and seeds and stuff. So those like plants and fungi, as well as a lot of local labs that can do the soil testing part. So I've been hearing labs are pretty overwhelmed right now too. So I just wanted to bring in that piece because I totally agree. I think we could develop a regional climate resilience plan that includes soil testing and ecological remediation as a major component, where we identify sites in which ecological remediation is most suited and most appropriate, and support and grow out these local sources of, plants and fungi and the materials needed to carry that out, as well as training teams of folks that can carry this out. It's kind of like it could be a whole new economy around regeneration, regional regeneration, and climate resilience. It could look quite different.
I love hearing that. I love hearing that so much. Well, here, let's do something fun for a second. It might make you a little uncomfortable. Imagine CARE were the, Los Angeles County remediator of record, and you were like, you had to sort of run this, knowing what you know. What would be the steps you would take? And also, let's, we're waving our magic wand, so funding is not an issue. What steps would you take, sort of leading CARE and having CARE work, in harmony with other groups and initiatives and universities and all that?
Ooh, this is fun. Okay, I'm ready. um, may have thought about this before. So I would love to see CARE have a home, like a warehouse where we could have our labs. We'd have an amazing soil testing lab, not just soil. We'd have a contaminant testing lab where we could test water, air, and soil and waste for a whole range of contaminants. We'd have our lab to produce the native fungal inoculum that's needed at scale. We would probably keep partnering with, native plant nurseries and stuff for those, native seeds. And then we'd have our research home where we could be continuing to carry out research moving forward through these, again, like a regional scale pilot where we select the sites most impacted by climate that would make the biggest impact in terms of environmental justice and climate, and target those in a massive remediation pilot. We'd continue to offer workforce development and educational programs for bioremediation. They're always linked to pilot projects so that the participants can get hands-on experience and actually learn through seeing and being involved hands-on. It would be so cool to offer an accredited like courses in this too. To my knowledge, you can't study this anywhere. It'd be so cool to offer that through a community college or another institution locally. That would be the vision, I think. And I will say,
Amazing.
yeah, we are lucky to already work with an amazing network of partners, from agencies to community organizations, tribes, and academic and research institutions too. So definitely would want to keep up that network building and that kind of collaborating wildly.
Literally, yeah.
Yeah.
Um,
Oh, I have another thing. Sorry, I have to say it. Because this is getting really nerdy and detailed, but I do think there's a lot of room for creativity here too. And there's byproducts that can still be produced even when working with ecological remediation, right? So if you have a contaminant like lead that doesn't break down, and you remove it with plants, now those plants have the lead in it. And there's a huge opportunity here, if we had this dream lab warehouse, to explore further circularity, right? So I've been playing around with making sculptures and micromaterials out of some of these byproducts, but there's potential for making biofuels and all kinds of other products, essentially, to support a more ecological and climate resilient economy in the region. So it'd be cool to test that too through care.
oh yeah. Oh yeah. Yeah, this is super exciting to me. I've said the following probably too many places, but I think it's so apt for this discussion, which is in the original Greek, the word apocalypsis referred to unveiling rather than doomsday, or end of the world. And that little sort of factoid kind of came out with COVID, or that's where it began sort of recirculating because of this magazine article. And I've been thinking about it a lot lately, and I'm especially thinking about it in this conversation where it's like there are very few images that could outdo. There's one. It's obviously like nuclear fallout, but south of nuclear
Mm,
fallout, the next scariest apocalypse I can think of is a hurricane of fire. And
yeah.
unfortunately, the one we just experienced is only a sign of more to come. And so if we take this apocalypse as the unveiling that it is, and really understand that that's a distress signal, that's an alarm, and we meet that moment to get back into alignment with the natural processes that have made this life on this planet survive, um,
Mm,
that's such a thrilling prospect for me. And so it's like I want to simultaneously like be very excited about that prospect and also be, I'm not putting forward like we should be excited about the devastation because it means we might get our act together.
yeah.
But like your work is really giving us a way to see one way that we might respond to this mega catastrophe, and really not only address the harms of that mega catastrophe, but also institute processes that make us more resilient toward the future.
Yes, absolutely. And it actually reminds me of my original inspiration personally for getting into this work, where I just grew up in a place that had been in an economic recession for a long time. And because of that, because the industry that was there had sort of shut down, by the time I was old enough to go walking around, I got to witness how nature heals itself, and how when you walk away, walk away from this industrial kind of culture that we're in, plants, fungi, all kinds of life comes back. And I think seeing that from such a young age was a big inspiration to me. And so with this work, it's really, nature is going to heal itself, right? It's like, if we just, let it be, and in a while, probably too long for our human time scales, we'd have, plants and fungi and bacteria and all kinds of stuff coming back and regenerating. So the processes of ecological remediation that I'm advocating for here, we're just leaning in to support that and to sort of accelerate that healing that nature is already doing. And so it goes back to that piece or that advice before about slowing down. Because when we really slow down, we can observe and listen to, what a specific landscape is needing and how we can best support and accelerate regeneration. And yeah, it could look, LA could look very different. It's a tragedy that that these fires have caused such devastation. And it's also kind of a checkpoint maybe for, what do we want LA to look like? Do we want to rebuild with, like I'm picture, the Matrix is coming to mind right now, like this machine, like world type thing, or do we want something different? I think that it can be so overwhelming. Things are so overwhelming right now, and at the same time, there is so much that we can do. And I keep, like, personally, despite overwhelm and stuff, having seen myself how much regeneration can happen in such a short time, with a really clever approach. I guess not clever. I just mean like a thoughtful approach. It's at least been inspiring for me to keep going and sharing this stuff. And yeah, I think going back to the apocalypse, true meaning, it's interesting. I read this poem recently that keeps coming to mind. I keep sending it to people. It's called How to Abandon Ship. And just, I think it's a really good kind of poem for these times, where it's like, okay, the ship is maybe sinking. It's going down. Maybe it's time to abandon this like hyper capitalist ship of destruction and war and poison, and build a new ship together. And it's like, yeah, time to abandon ship, I'd say.
Yeah. That message is coming through loud and clear. To that end, say somebody hears this or watches this and thinks like, oh, I want to get involved or I want to help. How do people get involved with CARE? How can people help? What are your needs? Like, how do we transmute these good ideas into, more action?
Find us online, ecoremediationscience.com, to keep abreast of upcoming webinars, workshops. I'm going to be doing a bunch of workshops in the coming months, specifically about fire, ecological remediation. And yeah, we collaborate wildly. So if you want to collaborate in some way or support, yeah, please do hit me up.
Through ecoremediationscience.com.
That's it.
So just to maybe put a fine point on it. So does that include somebody who is a landowner, property owner, which has sort of experienced some degree of harm from the fires? Would that be a type of collaborator?
Yeah. I've been hearing from individuals or neighborhoods who lost homes or who have been experienced soil contamination from the ash. I've heard from schools that want to sort of rebuild and do a bioremediation program with their students as a form of kind of hope and action and education. It could also be, we work too with policymakers and and academic researchers, as well as just community organizations too. So we definitely, and tribes. So we work with we work with folks who need it. So please reach out.
You kind of like mycelium.
Yeah. Kind of like mycelium. Had pretty good role models.
Amazing. Well, I feel like we've discussed a lot and I'm so appreciative of your time. Is there anything else that we haven't gotten to, whether it's something that you learned in your past work, something that you're developing with care, or any other type of information that people should be aware of?
I also wanted to shout out to Co-Renewal. They're an amazing organization that's been doing myco-renewal research for a long time and have recently done some really neat fire mycofiltration research and come out with a web-based tool. So you can check it out at corenewal.org to find specifically for California. If you put in your site and a bit of other info, you can get tailored information based on their research into how to stimulate native microbes in the soil to help with some of those contaminants. So check out corenewal.org. We'll be continuing to collaborate with them for some of this fire response resources and webinars coming up.
Amazing. And I'm calling out ecoremediationscience.com one more time. Because what you're doing is so important. And again, thanks for taking a little bit of time to talk about it.
Thanks for having me on, Jesse. Yeah.
This podcast is edited and produced by Adam Labrie and me, Jesse Damiani. The podcast is presented by Reality Studies. You can learn more by visiting realitystudies.co. And if you appreciate the work I'm doing, please subscribe and share it with someone you think would enjoy it.